All right, double absolute values, part 2. All right, so remember yesterday we did the double absolute value problems. We started the single absolute value problems and we did the new method. We did the number line method. Remember, we determined where the absolutes were equal to 0. We drew the number line, so we defined the regions on the number line. We set up the regions based on the regions on the number line, solved the equations, and we did our checks. And remember, the check is simply saying, is the solution in the correct region? Okay, so remember how we did these. We established that -3 was a 0. To the right of -3 were positives, to the left of -3 were negatives. So we did that, and we came up with our solutions. We tossed out 2/3 because 2/3 was not less than -3, was in the wrong region. We kept the 8 because 8 is greater than -3. Okay, so that's what we did the other day. All right, now we're going to look at double absolute values. So now double absolute values actually become, they're a little bit longer. That's the only thing. We're still going to use the number line method. If we did not use the number line method, and we did it that old-fashioned way, 1 part positive, 1 part negative, this is what it would look like. Okay? This is what it would look like. We would have 4 equations. Okay? Well, how? Well, first we would have 2 equations that were positive, because there's 2 absolutes here. We can't just say one's positive, one's negative. Well, they both could be positive. They both could be negative. Or they could switch. One's positive, one's negative. The first one's negative, the second one's positive. Okay? So that would give us 4 equations to be solving. And we don't want to solve 4 equations. Then it's more of a pain in the butt to check because we would have to plug in all of those answers. Okay? We would have to plug in 4 different sets of answers. And if we had fractions, that's an awful lot of work. Okay? So we're going to go back to that number line method, and you'll see what happens when we do the number line. So first thing I'm going to do is draw my number line. Make it nice and big because we have the regions. The reason why, you'll see why I'm making it big. Now, when does this equal to 0? At +3. This is equal to 0 at -5. Now, when you do your number line, make sure you put the numbers in the correct order. If not, you'll get wrong. You'll get wrong answers. Okay. So -5 goes first, and then I'm skipping space. I have my 3. So I got my. Notice now we've created 3 regions. So having 3 regions then means we only have 3 equations. Whereas here, without doing the number line, you had 4 equations. Well, hey, 1 less equation to solve. Establishing my regions. All right, so I'm going to make this x is greater than or equal to 3. Here, we're going to be in between -5 and 3. So -5 is less than or equal to x, which is less than 3. Remember, I excluded it here, but I included it here. It's just the technicalities. And here we have x is less than or equal to, strictly less than -5. Strictly less than. All right. Now, doing my equations. Setting up my equations. Here you got to be careful. In years past, I would set up the equations in each of the proper regions. Now, these last couple of years, I've been doing it a little bit differently. Okay? What I do now is I establish each individual absolute value unit, whether it's positive or negative. And I think it goes a lot faster and it's easier to see. What do I mean by that? All right. I'm going to start here at -5. -5, I'm only looking at x plus 5. Okay? So at x plus 5, when I am to the left, it is negative. Okay? Actually, you know what I'm going to do? Just so it's easier for me to write, I'm going to start with this. I want to start with this x minus 3, so I can put the x minus 3's first on all of these. Okay, so with that said, if I'm starting with x minus 3, I'm going to start with this 3 right here. So if I'm starting with this 3 right here, to the right of 3, this is positive. To the left of 3, this is negative. So what does that mean? Well, to the right of 3, I only have one spot to the right of 3, x minus 3 is a positive piece. Drop the absolute value. Then I'll put my plus sign. To the left of 3, this x minus 3 is negative. Here we are, 2 regions to the left of 3, x minus 3 is negative. So negative the parentheses, x minus 3. Okay, here we are. These are to the left, they're negative. Okay, I'll let you digest that for a second. To the right of 3, so to the right of 3, we're looking at this one right here. To the right of 3, x minus 3 was a positive result. Here we are. We dropped the absolute values. To the left of 3 in these two regions, they're left of 3, the x minus 3 was negative. So here we are, negative and a negative. Okay. So now I just have, now we have to look at the x plus 5s. All right, here's negative 5, my dividing line. Everything to the right of negative 5 is positive for this piece. So when I plug in, what do I mean by this? So when I plug in a negative, a number bigger than negative 5, negative 4, negative 3, negative 2, negative 1, 3, 4, 5, numbers inside here are positive. Okay? So negative 4 plus 5, negative 2 plus 5, negative 1 plus 5, 10 plus 5, they're all positive results. So everything to the right of negative 5, this piece right here is positive. So I'm just going to drop the absolute values. And let me finish off by saying equals 10. And then to the left of negative 5, this piece is negative. So negative the parentheses, x plus 5 equals 10. Okay? So a little recap here. Put this one in blue. So to the right of negative 5, everything in here is positive. So these were your positives and your positives. And then to the left, it was negative. Okay. All right. I have 3 equations to solve. Let's get these equations solved, and we'll see what we'll check out the results. So I'll distribute the negative. So, all right, I distributed. Now I'm going to collect. I'll add 2. And I'll divide. And now I'm going to take care of my answer. Is negative 6 in the correct region? Yeah, negative 6 is certainly less than negative 5. That's a keeper. All right, let's solve the middle. I'll distribute the negative. And I'm going to collect my like terms. Oh, look at that. Negative x, positive x, they cancel out. 3 plus 5 is 8. 8 equals 10. Pause. Look at that. What does that mean? That's right. That's a false statement. So that literally means there are no answers in between negative 5 and 3. It gave you a false statement. They cancel out. No big deal. We only have one answer so far. Let's see if this side exists. Combine. Subtract 2. And I'll divide. Well, we came up with 4. Is 4 in the correct region? Yeah, 4 is certainly bigger than 3. It's a keeper. So here we only had 2 answers, negative 6 and 4. 2 answers, negative 6, comma 4, using your fancy squiggly brackets for our sets. Okay? X equals -6, X equals 4. It's the fancy squiggly brackets. This is not interval notation. All right, done. Let's look at number 8. Nice 3 easy equations to solve once you get them established for the absolute values. Looks like I like 5s and 3s. Here's another 5 and 3 right here. So this is a +5, this is a -3. So -3 is on the left, +5 is on the right. Now I'm going to do my inequalities at the top. So x is greater than or equal to 5. Here we're in between -3 and 5. And then here we are less than -3. Remember what we talked about before. You have to include these we have to include these critical points somewhere. So I included it here and I included it here. It doesn't matter. You know, based on the inequalities, you're including them somewhere. These are just the technicalities of the process. All right, so let's get this one solved out and see what happens. Again, you know what? I'm going to start with x minus 5 because it's written first. So it's easier for me to do my equations in here. All right, so here's 5 right here. Remember, everything to the right of 5, anything inside here will be positive. 5 makes it 0. To the right of 5 becomes positives. So x minus 5, I'm going to put my plus sign. Then to the left, they are negative. So negative the parentheses, negative the parentheses. So here's my x minus 5 with a plus sign. X minus 5 with a plus sign. All right, now I'm at -3. Now I'm at this x plus 3, -3. So to the left, it's negative. To the right, positives. So let me get these to the right knocked off here. So I got my, to the right it's positive. So I'm just going to write x plus 3 and finish off my equals 8. And then I got my x plus 3 equals 8. And then here I have negative the parentheses, x plus 3 equals 8. So now I got my 3 equations all set. I'll let you digest that. All right. I'm going to start solving. All right, so I distributed the negatives. I'm going to combine. I'll divide, subtract. Okay, x equals, what did I do? Subtract 2, I get 6. I divide by 2, -2, I have a -3. There, better. All right, what is this? Oh, wait a minute now. -3 is the critical point. All right. So, but according to this side, I'm not supposed to keep it. All right, we need to finish solving these now because we land on a critical point. We need to, let's get all of our things solved and then we'll look at analyze the answers. So here I'm going to distribute the negative. All right, now here, wait a minute, negative x, positive x, they cancel. I got 5 plus 3 is 8. Wait a minute, 8 equals 8. This is true. That means everything inside here is a keeper. No matter what number is in between -3 and 5, I can keep it. So now all of a sudden now, remember over here I established that I'm going to keep the -3. Well, we kept the -3 here. Well, it's not that we keep it twice. Here I'm supposed to toss it, but because of this statement, I get to keep it. That's like I said, let's finish solving so we can analyze. So 2x minus 2 equals 8. 2x equals 10. X equals 5. And again, here's your critical point. So since we landed on the critical point spots, we have to also look at what's going on in the middle. We can keep what's ever in the middle. So technically speaking now, all of your answers are in between -3 and 5, inclusive. So this is your interval notation saying every single answer that's in between -3 and 5, I can keep. Okay, so here's your solution. All the numbers in between -3 and 5, including -3 and 5. Okay, so that's one of those uniqueness that happens with the double absolutes. Sometimes we have two answers, exactly two answers. Sometimes we have wacky stuff that looks like this. All right. Last one. I'll let you. All right, let's look at our last question here. All right, we're going to do it the exact same way. I'm going to establish my number line. This is x equals 3 to be a 0. This is positive 5. Again, you see my 3's and 5's. All right. Here's my 3. Here's my 5. I'm going to do my establish just like I've been doing. X is greater than or equal to 5. We're in between -3 and 5. You know, if you really wanted to, you could use your interval notation here. Bracket, parentheses for in between instead of you writing x is greater than or equal to. And then here I want to say x is less than 3. Okay, now we do have a uniqueness in this problem because this 3 minus x is written backwards. You need to be very, 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 very careful if you see anything like this that's written backwards. That sort of throws off our positives and negatives, okay? That throws off our positives and negatives. All right, so let's take care of this one right away. Okay, so here's the 3 right here. Remember what normally, if it's written as an x minus 3, anything to the right is positive, anything to the left is negative. Think about it. So if I had a number like 2, 2 minus 3 is negative. Okay? Oh, actually, if I had a number like 2, 2 is on the left-hand side here, 2 minus 3 is negative. And if I had a number like 4, or 8 or 10, 4 minus 3, 5 minus 3, okay? Those are positive results. But this is written backwards as a 3 minus x. Now look at what happens. Now if I pick a number like 1, 3 minus 1 is a positive result. Well, what if I picked a number like -8? 3 minus a -8, that gives you a double negative. That's a positive 11. So because this is written backwards, anything to the left of 3 is a positive result. Anything to the right of 3 is a negative result. That is the uniqueness of when you have 3 minus x because it's written backwards. Be very, very careful if you see one like that. All right, so let me get this established in here. Here's my plus 2, plus 2, plus 2. Here's my equal sign, and my equal sign. All right. So we just established because this is written backwards, you have to be very, very careful. To the left was positive, to the right is negative because it's written backwards. All right, so x minus 5 is in the proper order. We're golden. Anything to the right of 5 is positive. Anything to the left is negative. So we have our 3 equations to solve. So let's get our 3 equations solved, and then we'll look at the answers. So I have 3 minus x plus 2 is equal to distributing -x plus 5. Okay? All right, look at this. -x, opposite sides, they're going to cancel. So I have 5 equals 5. We've seen that. That means that's a true statement. So anything to the left of 3 is a keeper answer. But I don't include 3 because we said strictly less than. We'll probably catch 3 on this. We'll probably catch 3. Why did I put negative there? We'll probably catch the 3 on this side. Okay? We'll catch it right here. We'll see. So distributing negative 3 plus x plus 2 equals a negative x minus 5, plus 5. So what am I going to do? I'm going to combine those. Let me do this in 2 steps. X minus 1 equals negative x plus 5. All right, so I'm going to add x to the right, add 1 to the left. So I have 2x equals 6, x equals 3. See here we catch the 3 now. Remember we included it here with the bracket? So I have 3 as an answer and then everything to the left of 3. All right, let's see what happens. What uniqueness is going on here? So negative 3 plus x plus 2 equals x minus 5. I'll combine. X minus 1 equals x minus 5. All right, look at this. My x's cancel. And I'm left with negative 1 equals negative 5. Well, that doesn't make any sense. Negative 1 does not equal negative 5. So this is not equal. This is a false. Okay? So that means there are no answers over here. So your answer is only, you can't just say 3, because remember, this was a true statement. So technically it's 3 and all of these values over here. So that's negative infinity to 3. Okay? That's some of the uniqueness that we can see when we do double absolute value problems. Okay? Okay. That was part 2. You guys can finish up all your homework now.